Hello everybody, glad to see you. Today we're gonna talk about position control. As you can see at top left we have this component and we are going to have this composite positioning control. We are going to have a cylinder with a diameter of 0.5 back to ABC. A is this plane, B is this mid plane here, and C is this mid plane. We are going to have this cylinder, it is fixed here. At bottom of this composite FCF, we are going to have another cylinder with a diameter of 0.2 back to A and B. These two small cylinders can move in that large cylinder when the distance between these two small cylinders is 26. We are going to control the location of these two holes respect to each other. But at the bottom, we are going to have the same component and we are going to have two individual feature control frames. For the first one is the same as before, but for second one, we are going to check the parallelism for them, for both of them. We are going to have the cylinder with a diameter of 0.2 back to A and B. These two cylinders are free to move in that large cylinders. Just they should be parallel respect to A and B in that small cylinder. In this example, we are going to control the position and orientation of these two holes back to ABC in horizontal direction. In this direction, we are going to have offset of 1.5 between these two parallel surfaces. And for vertical direction, we are going to have the offset of 0.5. In order to have a gauge, we can calculate the size of gauge based on the modifier for both of them. We are going to calculate the smallest possible diameter or size of the hole, let's say. Here in horizontal direction, we have 13 minus 0.25 minus 1.5. We can see what should be the length of the gauge, and for width we are going to do the same. We can calculate in this one is 6 minus 0.25 minus 0.5. We are going to have this gauge for both of them, and this component can rotate and move based on having these two gauges here. Let's see this example. We are going to have two small holes with a diameter of 8, and we are going to have one large hole with a diameter of 10. Let's see this one for the small holes. We are going to control the position of that. We are going to have a cylinder with the diameter of 0.2 back to ABC. If we want to talk about the gauge, what should be the size of the gauge? Here we can see we have modifier, the same as before. We can calculate what should be the maximum size of the gauge. It is 8 minus 0.1 minus 0.2. We are going to have this gauge with a diameter of 7.7 for both of them, for these two small holes. And for large hole, in the same manner, we can calculate what should be the size of the gauge. 10 minus 0.1 minus 0.5. In this manner, we are going to have this simulator, and then we can calculate what can be the maximum distance between the center of small holes to the center of large hole. Here we can see What is this distance in this yellow area on left hand side? Here it is 8.1 minus 7.7 divided by 2. We can find the distance between these two center, and then in the same manner we can find what is this distance. It is 10.1 minus 9.4 divided by 2. We can find this distance, and here this 0.2 and 0.35 plus 20 became 20.55. It can be the maximum distance between these two holes. In the same manner, we can calculate what can be this minimum distance between center of this hole and large hole. Let's see the last example for today. Here, we are going to control the center of this small hole back to ABC. I would like to talk about the gauge. What should be the size of gauge? Because we are going to have these two modifier for this datum reference B and C. For B is center of this hole. B is this one. For B we have modifier, and B is the hole with a diameter of 18 to 18.6. Whenever we are going to have modifier, we should have the maximum material exists for this hole. It is 18 and minus 0.2, it becomes 17.8. As we can see here, we are going to have this size of gauge for that. And then we have C, and also we are going to have modifier. C, we are going to have this gauge, let's say 12.2 minus 0.2. We are going to have the maximum material exists for this. In this manner, we are going to have these two gauges. Conceptually, I can say whenever we are going to have this modifier for datum reference, we are going to have this mobility. We can shift the component. We are going to give more freedom to that component. This is M for datum feature, let's say shifting, mobility, something like that. However, theoretically, we cannot add, for example, we cannot add, let's say, the same as here, let's say it is come to the tolerance, but somehow we are going to increase the TZ. However, it comes through the shifting, and as we can see here, it comes because of the shifting, because of the mobility. For now, I would like to close this session. In coming session, again, I'm going to talk about the position control. Thank you for today. I hope you enjoy it. See you next time.